All right, so basically what we're going to be doing is talk about how to set up some math problems, and most of the time we did do some ratio stuff at the beginning of the year. That stuff is going to come back. There's one reason why we talked about all that. So what is a mole? Why are these, well, these are not moles, obviously they're prairie dogs, but yeah, everybody confuses them with moles. Moles are little creatures that can't see, that are digging underground. However, in chemistry, we use it as a short kind of summary of what we use for molecules. I will tell you, mole does not mean molecules. Do not get that misconception. It does not mean atoms. There is a ratio that we have to actually deal with. So there's many ways you could do all this, and that's basically what we're going to run into. I will tell you, everything in this unit is nothing but ratios. That's all it is. It's just we're looking at things on a gigantic level. All right, so how many eggs are in a dozen? 12. You already knew that. So anyway, when we talk about dozen, we're just talking about the regular egg dozen. Why are we even talking about eggs? How does this have to do with chemistry and this more biology? Well, we're not talking about cracking the eggs. We are talking about the ratio that is between them. And this ratio is going to play a huge part. The only reason why this works out so much better and that you can understand is that you're common with this stuff. There's always, how many shoes are in a pair? Two. I mean, that ratio is always going to be there. So anyway, there are 12 eggs in a dozen, so 12 eggs equal 1 dozen. That is what we call a ratio. However, if I say I have 2 dozen, I have 24 eggs. And if I have 3 dozen, I have 36. And you can see the trend that we're going on here. But like on your bell work, it said how many eggs are there in a dozen, or in 2.5 dozen. Well, you already did it. You multiplied them. Okay? But there are many ways to actually go about doing this. And one way I want y'all to kind of get an idea is how to set up ratios. And we're going back in time here to how y'all used to do them in old algebra class. Because what if the numbers are not very whole ratios? What if they're decimals? What if they're other things? That's the kind of math you're going to end up dealing with. But just to let you know, it still works out the exact same way. Now, I'm only showing you this right here because that's how they used to do it in algebra. I'm going to tell you right now, I'm not going to do that. We're going to do things the chemist way. The chemist way is setting up the ratios in that whole little crisscross method and solving for your missing variable. You can do it that way if you want, if that makes more sense for you. And if you do ratios a lot differently and you've always done them differently, by all means, do it that way. But I'm going to show them one way. And it's really quick and easy. The reason why we do it the way I'm going to show you is because we got to do it one after the other. In other words, you're going to be doing big step conversions, which are like 5 steps, like 5 different conversions, and you're wanting to do it all at one time in your calculator. The reason why, that saves you speed, and second off, it gives you a more accurate answer. And you're going to find out some of the answers you have on the test, you're like, I can't find this answer choice. It's not exactly like mine. It's off by a couple decimals. That's because the answers I have on the test are put to the everything you put in at once. So anyway, so basically if you were to set up this ratio, you know, you got 2.5 dozen. You're trying to find out how many eggs are in that dozen, so you set them to a ratio. Well, then you set them equal to what ratio you do know, which is, I mean, what we know, what we don't know. So you would do 1 dozen on top and 12 eggs on bottom. And why do it this way? Well, when you crisscross, you end up solving for your missing guy, which gives you the value. This is correctly the way how they used to do it, or how they do it in algebra. That seems very easy, but what if you had to do many, many steps? Like, what if I wanted you to go to another step and another step and another step? It gets kind of cluttersome. And so there's a little bit easier way to keep things set up. And so that's what I'm about to show you, actually. However, in this class, whenever we do these next little bit of worksheets, you're going to have to show me all work. I've had students who get the answer right. Good for you. You're one of those ACT ready guys that's going to make a 30 on it and do it all in your head. Congratulations. Okay. However, in this class, to make sure there are no cheaters, you're going to have to show me every little step of work you do. Okay. Well, not every little step, but just show me some work. Don't just throw down the answer. Plus, this is a one-step conversion problem, and in the units that's going to follow, you're going to have to do multiple steps in a timely manner. You're not going to have all day to finish this next test. So anyway, if I were to ask you how many tablespoons of egg whites are in 1.5 dozen, how would you actually figure it out? You're going to have to do a little bit more steps here. It looks simple. Yeah, it's easy. Now, let me go and tell you. Typically, in every egg, there are 3 tablespoons of egg whites, which is kind of, you know, just a fixed ratio. If you're doing it right, if you know how to extract egg whites. So no, there is not a ratio given for tablespoons to dozen. However, there is a ratio between dozen to eggs, and a ratio now between tablespoons to egg. Okay, but there's not one directly from the tablespoon to the egg. Okay, so first off, you're going to need to know your ratios, like I just said. So first off, we know that 1 dozen from the previous problem is 12 eggs, and we just told you right here in parentheses what's the ratio between the tablespoons and the eggs. Sometimes they have to give you a ratio. And those parentheses really do help you out. They're not just throwing it up there for no reason. But notice that they don't give you 1 dozen equals how many tablespoons of egg whites.
No.
But you could figure it out, because if you know that there are 1 dozen in 12 eggs, and then 1 egg equals 3 tablespoons, all you got to really do is kind of shift your ratio. Instead of changing the values that you see right there, all you need, though, are these set values. In other words, these are set. They're never going to change. All you got to do is plug them into your formula, and then you find your missing value. So I'm going to take this slow, because the setup here is most crucial. If you can get the setup, I promise you, this next unit is going to be easy. It's all about the setup. If you can't do the setup, you can't do any of this. And the setup is not hard. People make it more difficult than it really is. Really, truly. There's one class, if you're planning to go to any kind of nursing school or anything like that, there's a class you got to take. It's called dosage. And it's the only thing you got to do is do these ratios. Like, not just these ratios, but obviously medical ratios, like how many milliliters are in 1 cc, things like that. Just set it up. Don't worry about why it works in math. Just do it. The why will come later. All right, so how do we first set this up? First off, we do something I like to call a crisscross. Some people call it train track method. Some people do it different ways. But I set up a crisscross that you see right here. It always helps out because it breaks down things. So first off, know your ratios. If you don't know your ratios, you can't do the crisscross. Okay, so you got to figure out what's equal to what. Once you do that, all it is now is figuring out where to plug things in at. First off, when you set up your crisscross right here, you get your little table set up. Right here is always where you're going to start. Okay? Always set up like this. I think of it like a board game. Okay? I think right here is your start position. So anything they give you in the question, put it right there. All right? When I start doing these and you get the rhythm down, it's like seeing the matrix code. And that's what we're going to try to do is get you to is getting that instinct. Okay, how this works down here. You're going to use your conversion ratio. The first part over here is just setting up what they have in the question. That's it. To get to that part, you're going to have to start plugging things in. Now, what do you put in this little ratio right here? Well, it's your ratios. The second part is always going to be your ratios and every part after. Okay? So that's why you got to have your ratios. The question is, how do you figure out what goes on bottom and what goes on top? Basically, one of these two guys that are set equal to each other is going to go on bottom, and the other one's going to go on top. Always start with the bottom guy. Again, always start with the bottom guy. Basically, whatever unit this guy has, that's got to match it right here. It's like playing that matching card game where you're flipping over the cards and you're trying to find the two that match. That's exactly what you're trying to do here. By doing that, the other guy will automatically be on top, and you'll have your ratio set up every time. Guess what? It'll work like this every single time. There's no difference. It will do this. I swear. It'll work. You just got to do it. The thing then, after you put whatever you figure out the unit is on bottom, let's say like I start with dozen here, I'm going to put dozen down here. Well, if I put dozen down here, then I'm going to put 12 eggs on top. And that's really it. You just got to think what's got to go on bottom to cancel out. If you keep that in your head, then you'll do this right every single time. It'll be a piece of cake. It's you getting that rhythm down. Now, we're going to practice the rhythm tomorrow. We're going to dedicate a whole day of working out problems together in class. By the way, the rhythm that you'll always see is start, plug it in, find your ratio. That's going to cancel out this guy, and then put the other guy on top. Multiply, cross, and divide. All right, don't worry. We're going to do some samples. So in other words, what I mean by multiply, cross, divide, what you've done is set up a fraction ratio. What I'm saying is whatever value you add here, you're going to multiply across. And then down here on the bottom, that's not a 0. You just kind of leave it blank. It's kind of saying it's basically this over 1. We just don't have a unit for the 1. Just say, I just leave it blank. It's just, but if you want to put a 1 there, you can. So, all right, so let's plug everything in, actually tell you what I was talking about. So go back to your question, how many egg whites are in 1.5 dozen? Well, that's going to be the first thing we plug in. There's your start. So, where am I getting this 1 dozen from? From the... Let's go back. Okay. So where did I get that 1 dozen from? That ratio. So first off, guys, you got to have your ratio. Okay? If you don't know your ratios, you can't plug anything in to convert. These are set ratios. Sometimes I have to give them to you, but there's something that you got to memorize. Like, obviously, you should know what 12 eggs or 1 dozen is. I know you don't know that 1 egg gives you that many egg whites. All right, so let's go back. So you got your thing plugged in. Here's where you put your ratio in. How do you know what goes? You know you're going to use that ratio. 1 dozen equals 12 eggs. So how do you know what's going to go on top and bottom?
You have to cancel out the dozen.
That's the reason why. Why does the 1 dozen have to go on bottom? So it can cancel out. You can't put 12 eggs on bottom because they have to be crisscrossed to cancel. That's how the conversion ratio will work. If you remember, they got to be crisscross. I promise you, you'll get every question right if you plug it in your calculator right. Okay? I swear. Because that's what happens. Dozen cancels out. Okay? That's how we're going to end up doing this whole ratio thing. So we're not going to do it like you probably have done in other algebra classes. We're going to do it the chemist way. Well, when you've done that, what unit are you left over with? Eggs. Let me show you what happens when you don't put them in right and why you can't flip them. Okay? You got 1.5 does. If you put 1 dozen on top and the 12 eggs on bottom, okay, you'll get this. You'll get 1.5 over 12, which put that in your calculator is probably some decimal, but your units are going to be stupid. What I mean by stupid is this is going to be your units. When they're across from each other, they don't cancel out. What happens? It stays the same, but it actually squares. Okay? So you would have this over eggs. What good is that going to be? That's why it's very essential that you guys figure out what goes on bottom. All right, so what you've done is take your dozen and you turn it into eggs. You're done with that unit. But the question says they want it in egg whites, or I'm sorry, tablespoons of egg whites, not just eggs. So all you got to do now is figure out your next step of your ratio. Okay? So let's see if we can do this without me going through the slide beforehand. All right? What is your ratio between egg and tablespoons? How many tablespoons are in an egg?
3.
There are 3 tablespoons in 1 egg. You have 12, well, they say you have 12 eggs, but you have technically 18, right? So in your head, you're thinking what you're going to need to do. Multiply or divide?
Divide.
You're going to divide?
Multiply.
Multiply? This is the reason why the setup helps, okay? So I'm telling you, this is the reason why I want you to work and do the whole setup thing, because without you having to overthink, okay, do I multiply or do I divide? With the setup, it does it all for you. You'll never miss it as long, I swear, if you do the setup thing, it'll help out. So let's say you're done with this. That's canceled out, okay? So your little next setup, all we do is just kind of extend it along. So we got our next ratio, which is 3 tablespoons is in 1 egg. Well, what would be the ratio need to go on bottom to cancel out the eggs?
Do 1 egg on bottom
and
then 3 tablespoons on top.
3 tablespoons on top. You can put it all in your calculator then at once and knock it out. So technically you are going to multiply. You could tell at the end because the 3 tablespoons would go on top. But let's go through it all that, okay? Normally you would stop right here if they were just wanting just to know eggs, but they don't. They want to know tablespoons. So we got to keep going. So number 4, it's not a one-step problem, usually, I'll go ahead and tell you, they're most likely not going to be a one-step problem. I hate to break it to you, but we will do a few to get you kind of warmed up. Most of them are going to be step-by-step convert kind of thing. 4th, plug into your molar ratio to convert. Refer back to the first step. It's the same thing. You're just doing this the whole time. Cancel, new conversion. Cancel, new conversion. Cancel, new conversion. Cancel, new conversion. It's going to be like a lightning bolt, zigzag thing every single time. Key in converting. I don't know how I can stress this even more. I repeated it like 5 times already. All right, so there's our ratios that we talked about again. 1 dozen equals 12 eggs. Well, we already used that. So our next ratio is 1 egg equals 3 tablespoons. What you would need to do then is figure out how to get rid of these eggs. Well, what needs to go on bottom? Matt just said it. 1 egg, and then if the 1 egg went on bottom, the 3 tablespoons go on top. So let's see what it looks like. So what we do, take the same problem and just extend it. And again, you're like, well, this is kind of stupid because we're doing eggs and dozen. Well, I got to give you something you can relate to that's easy. Then we get to the chemistry part. All right, so we extended along. We just said it. What's got to go on bottom? Eggs. Why do I cross it out? So you don't get confused.
Yeah.
It always helps once you've done that to cancel out. So one egg goes on bottom, so I put that here. Then that has to go on top. If you put that one egg on bottom, that has to go on top. If they're set equal to each other, that's how you figure it out. You could flip-flop them any time, but there's a reason why we put it on bottom, so it can cancel out. So guess what your whole big math problem really is? You're going to multiply everything on top. Keep in mind, this is like one big fraction, okay? So 1.5 times 12 times 3 is what? 1.5 times 12 is 18. 18 times 3. 54, okay? So 54 would be on top. All right? Well, if you multiply 1 by 1, that's going to be what?
1.
1. So notice this. What units are pulled along? None of these that are crossed out. Only the unit that the question asked
So
for.
it's going to be 54 egg white.
And so 54 divided by 1 is what?
54.
Yes, 54. Tablespoons of egg whites. By the way, you can't just write down the word 54. Or the letter, or the number, or whatever. You have to write the unit. If you don't write the unit, guess what? It's wrong. Please, if you do the math, which is the hard part, don't forget your units. If you just put 54, that's a naked number. Just put the whole thing in your calculator all at once. But if you do that, put this whole thing right here in parentheses. Okay? So if you were putting this in your calculator, you need to do this. That in parentheses divided by this in parentheses. Don't forget your parentheses in this unit. Okay? They are very essential. Basically, I'm going to tell you this. When in doubt, put a parenthesis in. They'll work out in your calculator no matter what. The calculator will read it right even though you can't. Because here's the problem. This works out fine if you did just do 1.5 times 12 times 3.5 divided by 1 times 1. But that's not how you really, the only reason why it worked out is because that's 1 and 1. What if they were different units or different numbers? That means you'd have a problem. A lot of people have calculator issue in this unit where they don't put in their parentheses. And I'm going to warn you, in your parentheses. Okay? Okay? So, we're going to practice putting in some parentheses today. So mastering these steps will help make this class a lot easier. And again, I stress this a lot because it's important. It's a skill that you'll take with you, not just in this class, but in other math classes. And it might actually make your math class a little bit easier once you get to ratios, if you like doing it that way. But who knows? All right, so they talked about this weird guy, Amido, Abrigado, Lorenzo, Raritos. So anyway, so basically, 1 mole actually equals this big long number. But instead of you memorizing this big long number, we sum it down in scientific notation as 6.022 times 10 to the 23. So 1 mole equals 6.022 times 10 to the 23. And then you're like, well, what's the other unit? Well, that's of anything. In other words, if I say I have a mole of candy bars, I have 6.022 times 10 to the 23rd. Is that a lot?
No.
Yes, that is a lot. Look at the number up here. What I'm saying is if I have 1 mole of candy bars, I have this many candy bars.
Who takes that much time to figure out a number?
I'll go ahead and tell you, nobody, let's put this in ratio. Thousands, you got billionaires, and then sometimes you got a few trillionaires if you're old king. All right, nobody has got beyond this ratio. Okay, I want you to keep in mind. So if you had a mole of dollars, in which they did tell you in the video, if you had a mole of dollars, or if you had a mole of pennies, actually, I'm sorry, and you spent $1 million every day for your whole life for 100 years, you still would have a lot. What?
I thought he said every minute for your entire.
Oh, every minute. Well, that's even bigger ratio. I thought it meant every day. You still would have like a bunch left. Atoms are very small. They're very small. We don't see them. You can't see them with the naked eye. We sum them up in terms of moles. It makes things a lot easier. So just to keep in mind, just to give you an idea of the ratio, so if I had a mole of basketballs or a mole of candy bars, I would have this number. If I had 2 moles, then how much of this stuff would I have? Well, then you would take this whole number in parentheses and multiply it by 2. I cannot stress this enough that you put this number in parentheses every time you use it. All right, so if I say I have a mole of candy bars, how many candy bars do I have? 23rd. By the way, you're going to have to memorize that. Yeah. If I have a bowl of pencils, how many pencils do I have? Same number. If I have a mole of H2O, How many molecules of H2O do I have?
That's why mole day is October 23rd.
Yeah, you figured it out. 1023 is actually the reason why. And that's how you can memorize that. But 6.022 times 23rd. If you keep saying it real fast like that, 3 times fast, you'll eventually learn. So anyway, if I have 2 moles of H2O, I have this doubled, okay? Now, if you put this in your calculator might do something funny, okay? If it's in scientific notation, it'll put it in there pretty good. But some of y'all might think you'll just have this number doubled, which you're right. But your calculator might move that decimal over 1 and go ahead and give you that power. I'm going to tell you that power is another thing people mess up on. They still think it's all 23. Keep the power correct. Your calculator is going to be your greatest ally in this. So double check every time you plug it in. And I'm telling you, if you just put 2 times this in parentheses, anyway, 2.5 dozen, which you're going to end up with decimals a lot. You're going to have to multiply that by basically the 6.022 times 23rd. But this is all fixed kind of ratios. They're set up a certain way. And these are kind of the questions I'm going to end up asking. I go over this first because this is the most important part, is why do we use this number? In reality, if I have a 1 mole of H2O, I have this many molecules, okay? And that's a lot of molecules. In other words, the little structures that you would see inside the water, that's how many I would have. But anyway, let's talk about some of the issues. Now, some of y'all might be using, thank God I got you those calculators. Did your calculator pop up EE at all? The ones that I bought y'all? Not at all? Thank goodness. If you haven't one of them fancy schmancy calculators they tell you got to have for calculus, or for math or algebra or whatever, I will tell you, this pops up. It'll say e to the power or EE, okay? Let me go ahead and tell you this. If you ever write, if you could use those calculators, fine. But do note that the EE and all that stands for to the power of the 10, okay? In my class, if you write down that as your answer, you get it wrong, okay? You don't give me E. You give me E, I give you F, okay? Very simple. No E. But if you're using my calculator, you shouldn't have this problem. That's one reason why I bought those, because they're a little bit easier to use. Fantastic. All right. Had to go over that real fast. All right, so going back to the mole, so we're talking about all these kind of things, what we can do for molecules. Now the question is, well, how do we measure a mole? Okay. Well, you got to know this. How we're going to use this in this unit, okay? Obviously, if we get the mass of a certain unit, which I haven't showed you yet, but I'm about to, that can tell you how many moles each of these are. Now, do realize like every element is different on the periodic table. And one reason why is they all have different masses. Well, I'm about to explain how we can actually do this in lab and figure out how many actual molecules we actually have. And it's very useful. So thanks to Avogadro, we have now the Avogadro number, which is 6.022 times 23rd. So if I say I have 1 mole of atoms, I have 6.022 times 23rd atoms. If I have 1 mole of molecules, I have this. I have 1 mole of particles, this is what I have. These are the 3 units we're going to associate with this 6.022 times 23rd. All right, this is something you got to know by heart. So in other words, if I say, find me how many molecules 2 moles of water have, you got to know you're going to multiply that 2 moles by this. And you know that your unit.
You're going to put that in parentheses and multiply by 2?
Yes.
Okay.
Yes, high five. So 6.02 times 23rd particles, most of the time you're going to see these 2 guys. When are we going to use atoms?
Never.
Close. You're very close. Whenever you see an element, like if I say iron, we'd use atoms there. If I said H2O, which is a compound, or NaCl, that's a molecule. Okay, so remember back in Unit 1 we said elements are atoms, compounds are molecules. That's when you'll see these things. We really won't use particles that much. I don't even remember using them in this unit, but I do know in physics they use the word particle. All right, so how are we going to use this in lab? All right, we cannot measure moles directly. We cannot take a thing of water, put it on a balance, and there's a unit conversion for moles. All right, there's no mole setting. The reason why you can't do that is because every element has a different mass on the periodic table. So what do? Well, we take the mass from the periodic table and we convert that to a set number of moles. Why do we have the periodic table? Here's the other thing. This is all equal to 1 mole. What? Okay, so for example, if I say I have, let's take the mass of carbon, 12.01. If I have 12.01 grams of carbon, I go in the lab and I measure out on the balance 12.01 grams, I have 1 mole of carbon.
Whoa.
Okay, let that sink in there for a second. Okay? Is it sinking in a little bit? So in other words, if I need to find what 1 mole of any element equals, I look at the periodic table. You're going to need your periodic table, by the way. Does anybody know the mass of water off the top of your head yet?
No.
Ooh. You were saying it? Somebody was saying it?
8.
It is 18.02.
15.
That was in the video. So if I have 18.02 grams, of water, guess how many moles I have of water?
What? Well, I thought a mole was that big old long number.
Okay, so if I have 1 mole of H2O, then how many molecules do I have?
Oh.
You just said it. I have then 6.022 times 10 to the 23rd molecules.
Whoa. Dang, I got myself.
So if you go into the lab, measure out 18.02 grams, like you did, get out of balance, you pour water into it to 18.02, you'll have 1 mole of water, and you'll also have 6.022 times 23rd molecules water. In other words, if you wanted to count every single molecule that was in that water, okay, that's how many you would have. So why do we not, this is just a huge freaking number for you to actually imagine. So we sum it up by saying the mole. It's just a lot easier to comprehend saying, oh, well, that's just 1 mole. It makes it a little bit easier as we go along.
Laser.
So let's actually go through in the presentation. I kind of jumped ahead. By the way, you're familiar with using AMU? All right, we're not using AMU anymore. AMU will now be replaced with G per mole. What is G per mole? Well, it's very simple. Grams per mole. That's how many grams are in 1 mole. So in other words, when I did 18.02 times the 18.02 grams, that's 18.02 grams in 1 mole. It's the same thing as AMU. We're just changing the last couple letters. That's it. Okay. All right, so now use molar mass, and that's what we're going to call it. Well, it was formerly known as formula mass, but we're not doing, we use formula mass when we're counting protons, neutrons, electrons. We're not doing that anymore. We're doing molar mass, where we're counting it in basically, well, equal to 1 mole. So in other words, give me a mass off the periodic table. Pick an element. Give me a mass. Pick one.
Let's go with rubidium.
Rubidium. All right. I don't have a periodic table in front of me. Rubidium's mass is 85.4678. If I have 85.4678 grams,
You got 1 mole of rubidium.
I have 1 mole of rubidium. Therefore, how many atoms do I have of rubidium?
6 times, oh, never mind. 6.022 times 10.
10 to the 23rd.
What? So is everything just a light bit?
I'll explain it to you later. You gotta get it.
All right, so let's try some of these out. How many grams are in 1 mole of H2O? This is a real chemistry problem, okay? Well, we kind of just answered it. Do remember that we are shifting this now. We're not doing AMU anymore. We're now doing grams per mole. That's a fraction, okay? So in other words, just like we just did a second ago, 55.85 grams of iron, I don't know what I was doing there, is equal to 1 mole. Another way of saying this right here is saying 55.85 grams per mole. Okay? You remember miles per hour? If you're going 70 miles per hour, how many miles are you going to cover in an hour? 70? Okay. All right, so if you're doing 70 miles per hour, the same way of saying 70 miles per 1 hour. Same thing as saying this is 55.85 grams per 1 mole. We're not doing formula mass anymore, we're doing molar mass, which is exactly the same thing, it's just a different unit. So how to figure out this problem? Well, you're going to need your molar mass, all right? This is the problem. Remember when we added up all the pieces of the mass and they equaled something? Yeah, you're going to do that again. But that was easy. So I'll go ahead and do it. You got water, which is 2 hydrogens, 1.01 plus 1.01, and oxygen weighs 16 grams. Add them together, you get 18.02. All right, we already talked about that. That's where we're getting the 18.02. You're going to end up memorizing that because we're going to use water a lot. It's everywhere. You can't get away from it. Well, here's the thing. This is 18.02 grams per mole. Well, then how many grams are in 1 mole? Well, we just answered our question. If 1 mole equals 18.02, then that's what it is. Does that make sense? That's exactly what the same crap we were doing over here a second ago. So in other words, for every 18.02 grams of water, we will have 1 mole of water. 1 mole of water equals 18.02 grams. That's a ratio. Hey, guess what? We're going to need that later. Okay? That's pretty easy if we say 1 mole. Everything's easy when we set it to 1. But if I had 2 moles, I would have how many grams of this? If I have 2 moles, you double it.
32.04.
There you go. Is he right? I don't think he's right. 36.
Close enough.
I was like, 34?
I'm proud of myself.
I'm pretty sure 8 plus 8 is 16. All right. So now if we were to say how many molecules, please don't get mole and molecule confused. They're 2 different things. Yes, they sound alike. Yes, one has the same letters as the other. But to do molecules, we can't use this ratio. We can't look at the periodic table. Okay? We got to use Avogadro's number, which was
6.022 times 10 to the 23rd power.
Okay. So yeah. So example 1, how many grams are in that? Well, anytime they, let me jump back. I'm sorry, I'm stupid. I know. Yeah. All right, example 1. Why did I go over this? I forgot my whole point. Why? I'm jumping past things what I should explain. All right, so we figured out how to find it, but why? Well, I'm going to tell you why anyway. When you're looking for word grams, if you see a question that says grams, and if you need to write this note down, go ahead. Anytime you see grams, you're going to look at your periodic table to find mass. That is a trick that I know whenever I see one of these questions. Like right off the bat, I know grams, periodic table. Okay, it needs to be like, you know, when a bird dog or when you whistle for a dog or something like that, and they're like, huh? You know, things like that. So that's what should happen. Your ears should perk up and be like, boom, periodic table, when you see the word grams. Because I'll go ahead and say, grams always going to involve this, 100% of the time. Where it ends is another question. You just know you're going to have to add up something. Okay, with that being said, if I said molecules, not grams, but molecules, you're going to have to use Avogadro's number. That should be in the next thing that clicks in your brain. So those 2 things you need to know. We're going to practice them more tomorrow. But if you hear the word molecules or atoms, you need to think Avogadro. Okay, you need to think 6.022 times 23rd.
Avocado.
Okay? 1 mole equals what? Well, let's go back. If we're trying to find molecules, 1 mole equals what? 6.022 times 10 to the 23rd. They really should do a Schoolhouse Rock special on this.
Oh, that shit. Oh, God.
I'm going to actually do a YouTube video on that. I'm just a bill. All right. Use Avogadro's number to find the molecules, atoms, or particles. Most of the time, though, you're going to end up finding molecules or atoms. We probably won't use particles. So to sum up the ratios, and this is of water. Okay, we're looking at H2O here. And you might want to write H2O off to the side if you want to. So we have 18.02 grams of water. That gives us 1 mole, which gives us this gigantic number of molecules. So like I said earlier, if you go into the lab and you measure out 18.02 grams of water, you have 1 mole, which then tells us how many molecules you have. Precisely. Notice this. Looks like you can go directly from grams to molecules. But I'm going to go and tell you you can't. Okay? Because what if I had 20 grams right here? This whole ratio then would shift. Okay? Well, one thing happens to this ratio. Do you realize this is fixed just for H2O? In other words, if I had 18.02 grams of NaCl, or salt, this whole ratio would not apply. This only applies to water. So this is one reason why you need the mass off the periodic table. Just realize this ratio will stay the same. Okay, 1 mole to that. But every time you screw with the element over here, you got to set it equal to whatever it is up there. Because all those equal 1 mole. All right, so let's go through some of these others real quick. So this is just like the egg problem that we just did, except those are more familiar ratios. I should put H2O right here, because that is waters. So just like the egg problem you just had, we found out that at the previous problem, 1.5 dozen equals 18 eggs, which give you 54 I'm sorry, not 54, just 54 tablespoons. Can that ratio be reduced? Yeah. It could be reduced to this, the ratio that you're actually familiar with. So in other words, 1 dozen equals 12 eggs. Well, if you have 12 eggs, each are worth 3 tablespoons of egg whites, then you have over 36 eggs of egg whites. Okay? The ratio is pretty straightforward between those. So yeah, there we go. So basically what we're doing is keeping the ratio set, but do realize if I have a dozen of, notice that works for eggs, but if I had a dozen of donuts, that's a different dozen. That's a baker's dozen, which is a little bit different. Note the ratio will always be the same, and it's always based on there. And you could write down a ratio for every single element if you really wanted to, but that would be over 118 elements, and then you'd have the many compounds that we actually have, and that would just be pointless. You're better off actually just figuring out how to do the math on the key. All right, so change one number, it changes them all. So in other words, if I change this to 20 grams, this whole ratio changes for water. All right, if I change this dozen, it changes this whole ratio. You just got to make up for the missing ratio by solving for the missing guy. I digress, though. So anyway, you cannot directly convert between grams and molecules of atoms without going through moles, is what I'm trying to say. So for example, let's do a quick 2 samples and see what we can get out of the way here as quick as we can. So how many grams are there in 2.5 moles of calcium nitrate? Okay. All right. So now you have that. Now you have your ratio. Because this equals not just grams, but grams per mole of that guy. In other words, that is this. So it's just like adding up the water, but now you have your ratio. So just like we talked about earlier, how do we get rid of this mole? Using the ratio you have. One of these two have to go on bottom. You have the 50% chance to get it right. Why does mole go on bottom?
Because that's how we do that.
Mole go on bottom. And then that goes where? That cancels out. What unit are you left in? So multiply that by that. So how did you do this? Well, you multiply this by that, and then you have that over 1. Well, that divided by that should give you this. All right, the next one. It said how many moles are there in 5.17 grams of this? You're going to need to do the same thing. Find the mass of this. First off, what did they give you in the question? The grams. Okay, so they give you grams. You're still going to need to find grams. So you need to get 2 moles. Okay? You need the ratio between moles and grams of Fe that. There's only one way you can find that. You just did it a second ago.
You got to find the mass.
So find iron. Find the, how many carbons do you have?
We've got
7.
You have 10. 10.
10 carbons and 10 hydrogens. Is
And how many hydrogens?
we got 10 of them.
Put it all together now.
We got 10 of them sapsuckers running around here.
That's going to be 120.1. That's going to be 10.10. Iron is 55.85.
Yeah.
So here's the thing. All right, now think this through. You got grams right here. So which one of these two got to go right here? The grams. If that goes on bottom, the 1 mole go on top. Boom. Boom. Multiply, cross, divide. You can divide by that.
Get some.
So you can't get a weird decimal. By the way, if you wrote down 0.02 or 0.03, incorrect. You got to give me at least 2 non-zero digits if it's past the decimal.